All right, so we learned about these compound fraction problems on Friday. So let's take a look at if we can do one. So the thought process you want to think here is there's basically two parts to this problem. We need to do this addition. Sorry, it's a bad parenthesis. We do this addition first. Once we figured that out, then we can go ahead and take 2x and multiply it by the reciprocal of this, because that's what we want to do for a division problem. But we really got to do this first. So off to the side here, that's what I'm going to do. We'll figure out what happens when I add these two fractions. So to add these two fractions, I need a common denominator. So this one I'm going to need to multiply by x over x, and this one by x minus 2 over x minus 2. Alrighty, so when I do that, I will have a common denominator of x times x minus 2. And up top, I'm going to get an x squared, a 4x, and a minus 8. Cool. So then I look at this and I say, can I factor this any further? Are there factors of negative 8 that add to 4? And I don't think so, because we only have, negative 8 and 1, won't add to that. Negative 4, 2, won't add to that. So no. So this doesn't factor, which is fine. That just means that this is as far as this one's going to go. So now, to finish this problem, I'm going to take this, 2x, and instead of dividing it by the fraction I just found, I'm going to multiply it by the reciprocal of this. So what I'm going to do is 2x times the reciprocal here. So that's going to be x times x minus 2 over this, this quadratic that didn't factor. Okay, so at that point, it doesn't look like we really have any cancellation. You can put this over 1 if that makes it easier for you to kind of think what's going to happen. Basically, we're just going to multiply these together, and that's going to become our answer. So 2x times x is 2x squared. Then we have this x minus 2. And we have the x squared plus 4x minus 8. And we should be good there. There's no cancellations that are going to happen. There's no values, nothing going on there. Now, we do run into a little bit of a sticky situation with our zeros. So what can x not equal? Well, there's a couple numbers that are obvious. It definitely can't be 0 or 2. But also, this is in the denominator. And this thing, we don't know if it has any real solution. So let's just check real quick. If we graph it, we'll be able to see if they're either decimals or if they're real. And that's going to kind of let us know what to do. So we could put it right in the quadratic formula, but I'm going to try to save myself a little time by just graphing it and seeing what it looks like. And so this actually is good. This has two decimal solutions. So there are actually two more real numbers that are decimals that I can't have. So since I got it on the calculator, let's go ahead and find them that way. So 0, we'll go ahead and do my left bound, right bound over here. So negative 5.46. And the one over here, looks like 1.46. Cool. And now I think we're good. So if we kind of recap everything here, the problem didn't do a whole lot of simplifying. We really never had anything to cancel at any point. But as far as our restrictions go, a little bit of weirdness here because we have the part that I think is fairly obvious. We can't have 0 or 2 here. That would give us undefined. But because this does get turned into a reciprocal, this is in a denominator also, and it had a couple decimal zeros. So yeah, 4 restrictions in this case, and that's okay. There's really no limit on your restrictions. It's anything that ever is in a denominator is going to restrict your values.